All right, so good day. We are now going to talk about the angle of elevation and angle of depression. So in this video tutorial, we are going to concentrate on solving problems related to right triangle trigonometry. So last time, we have discussed about the right triangle trigonometry in such a way that we use the different trigonometric ratios, sine, cosine, tangent, in order to solve for the missing sides and also the angles of a triangle. So now, we're going to apply what we have just learned in solving real life problems. So in this case, we will first discuss about the angle of elevation and angle of depression. So, let's try to differentiate between angle of elevation and angle of depression. So, we have here our definition. So, the first one is the angle of elevation is the angle between a horizontal line from the observer and the line of sight to an object that is above the horizontal line. So, if we have an observer here, and this is our horizontal line, okay? And we look for the object above. Okay, so meaning to say, because we have elevated our eyes, that becomes our line of sight. So in this case, this line will be the line of sight from where you are looking towards the object. So, from the horizontal line, you go above, you elevate your sight, okay, going to the object. So, this is what we call as angle of elevation. So, again, the angle of elevation is formed, okay, between the horizontal line and the line of sight of the observer, okay, that is looking above, okay, upward direction from the horizontal line. Okay, so that is our angle of elevation. Now, what is our angle of depression? So if we have an elevation, we also have a depression. So by definition, we say that the angle of depression is the angle between a horizontal line from the observer and the line of sight to an object that is below the horizontal line. So, again, we have this observer and we have this horizontal line. And if we look below towards the object, okay, so meaning to say, this will be our line of sight. Okay? So, that becomes an angle of depression. Okay, again, the angle of depression is the angle that is formed between the horizontal line and the line of sight below. Okay, so below towards the object that you are looking for. Okay, so this is the difference between the two, the angle of elevation and the angle of depression. So it's just a matter of how we formed the angle between the horizontal line and the line of sight, either above or below. Now, let's look at again this illustration. Okay, so this man is looking at an object above and below. So therefore, if we are going to consider this as the horizontal line of sight, so this is the horizontal line, and this one is our line of sight. Okay? So, if you're looking at an object, okay, above the horizontal line, so that becomes our angle of elevation. Okay, now in this case, this is again our line of sight, and this observer or this person is looking at an object that is below the horizontal line. So therefore, the angle that is formed is an angle of depression. Alright, so that is the comparison between the angle of elevation and then the angle of depression. Okay, so let's proceed. Now, in some cases, okay, we can draw the angle of depression and the angle of elevation as like this. Okay, now, question is, what relationship exists between the angle of elevation and the angle of depression? Now, looking at the figure, okay, so you have here your angle of depression and you have here the angle of elevation. So we can therefore say that based on this illustration, we can say that your angle of elevation is just congruent to your angle of depression. So let's write that. So the angle of elevation, okay, the angle of elevation is congruent to your angle of depression. Okay, now what is the reason behind? Okay, consider this line as parallel to this line. Okay, and this line of sight, okay, cuts the parallel lines. So therefore, what can we say about this angle compared to this angle? They are called alternate interior angles. And what do we say about alternate interior angles? We say that all alternate interior angles are congruent. So that is the reason behind why the angle of depression is equal to the angle of elevation. Okay. Now, let's again look at this. Okay, so we see that we have a tower here that is 40 feet. Okay, and then from the horizontal here, okay, so if there is a person looking, okay, downward to this person here in the boat, okay, so there is an angle of depression that is formed here that is 38 degrees. This will just be equal to the angle of elevation from this person if he will look up to the top of the tower. So an angle of elevation is formed in the same manner as the angle of depression. Okay, so they are just equal to each other because they are alternate interior angles. Okay, now let's look at this. Angle of elevation or angle of depression. So you're going to identify, okay, whether the illustration or this figure illustrates an angle of elevation or our angle of depression. Okay, so what does the angle illustrate? So this one. Okay, so we can say that this angle illustrates an angle of elevation. Okay, so let's proceed to the next. Okay, what does the angle illustrate? So this is the angle. Okay, so this angle illustrates angle of depression. All right. So, we're going to apply the angle of elevation and the angle of depression as we solve problems related to right triangle trigonometry. But before that, these are the different steps in solving problems related to right triangle trigonometry. So, number 1, read the problem carefully. Okay, number 2, draw an illustration of the problem to form the right triangle. Number 3, label the unknown side. So when we label, commonly we designate that with X. Number 4, use appropriate trigonometric ratio that will solve for the unknown. So you're just going to choose. So it's either sine, cosine, or tangent, depending on the given. And then lastly, number 5, we are now going to solve for the unknown and express our answer in proper units. Alright, so let's proceed with the problems. So this is the first one. So, from a point 80 meters from the base of a tower, the angle of elevation is 28 degrees. So, how tall is the tower? So, the first step is again, you draw. Okay, so in this case, we have already a tower here. Okay, now it says, from a point 80 meters from the base of the tower. So this is the base of your tower. Okay, now from a point that is 80 meters. So I will be extending this line, okay, from that base to a certain point here. Okay, and then this is 80 meters. Okay, now it is also said that the angle of elevation is 28 degrees. So therefore, from this point, going up, okay, so going up, so let's just draw a line. Okay, so going up, so the angle of elevation is 28 degrees. So this is our 28 degrees. Okay, now we have formed already a right triangle, I mean. So right triangle. Alright, so that becomes a right triangle. Now the question is, how tall is the tower? So how tall is this tower? So we're going to designate this because it's unknown as x. So meaning to say, we're looking for the height of this tower. Okay, so since we already have our right triangle, we are now going to solve. So again, we have illustrated already. So you are going to choose from the SOHCAHTOA, okay, whichever is applicable. So let's look at this. So I have this angle, I have the opposite, which is the unknown, and also I have the adjacent. So if I have opposite and I have the adjacent, so I have, okay, the angle, so I'm going to use the tangent. So we are now going to express this in terms of our equation. So tangent, okay, 28 degrees is equal to, so TOA. So x over 80. So that's 80 meters. Okay, now let's now solve. So solving for x, so we are just going to cross multiply. So this becomes 80, okay, times your tangent 28 degrees. Okay, or tangent 28. So that will be equal to x. Now using your scientific calculator, so that's 80 times tangent 28 degrees. Alright, so our x here, so the value is 42.54. Round off to 2 decimal places. So that is x. Okay, so therefore, we can conclude that the height, okay, the height of the tower is 42.54 meters. Okay, our units is meters. Right, so that's how we solve the first problem. Now let's look at the second one. Okay, so this is the second one. The angle of depression from the top of the tower to a boulder or a stone on the ground is 38 degrees. If the tower is 25 meters high, how far from the base of the tower is the boulder? So this is our illustration. So this is our tower. So this is our stone. Okay, now look at this. The angle of depression from the top of the tower. So meaning to say, from your top, you're going to draw a horizontal line so that you have a line of sight that is going down to the stone or the boulder. So making an angle. Okay, so that's it. Okay, so that's our angle of depression. That is 38 degrees. Okay, if the tower is 25 meters high, so that's that's the unknown. Okay, so this is the height. So that is 25. Okay, so how far from the base of the tower to the boulder? So that is our x. Now, how are we going to solve this? We have already the right triangle here. Okay, we have the unknown, we have here the 25. Now, what is the measure of this? So, since this is the angle of depression and this is our angle of elevation. Okay, so because they are alternate interior angles, we say that they are congruent. So, therefore, that measures also 38 degrees. Okay, so we are now ready to So if we have this as our angle of elevation, okay, this is our right triangle. So what are we going to use? So again, that's SOHCAHTOA. Okay, now let's look at this. So I have an opposite and then I have an adjacent. So that is tangent. So let's write the equation. Again, tangent 38 degrees will be equal to TOA. So 25 over x. Then we'll just cross multiply. So this becomes x times tangent 38 degrees equals 25. So since we're looking for x, okay, so we will divide this by tangent 38. Okay, so tangent 38 degrees divided by also by tangent 38 degrees. Okay, so cancel this. What remains is x. So that will be equal to, so using again your calculator, so we're just going to divide. So 25 divided by tangent 38 degrees. Alright, so our answer here is 31.998. So that's 3 decimal places. So if we're going to round this off to 2 decimal places, so that would be equal to, it becomes 32. Okay, 0.00. So 32. So our value for x is 32. So that's our answer. How far from the base of the tower is the boulder? So therefore, okay, our answer is the boulder. Okay, so the boulder is 32 meters, okay, away from the base of the tower. Alright, so this is how we apply or solve problems related to right triangle trigonometry. Of course, applying the angles of elevation and angles of depression.